In this video, I will take you through implicit partial differentiation. Before we can get to examples of implicit partial differentiation, let us try to remember the following. Let me say we want to differentiate 3x squared. How can we differentiate 3x squared? This is nothing but the derivative of 3x squared dx. And then the answer that we'll get out of this is 6x dx over dx, and dx over dx is a 1. Then we conclude by saying that our answer is dx. How about now when we want to differentiate 6y squared? We want to differentiate this with respect to x. Then the answer that we're going to get out of this, we must have the derivative of 6y squared with respect to x. Remember, we differentiate a different variable with respect to x. Then the answer that we'll get out of this, it means we'll have 12y. Because it's a different variable with respect to x, we'll always have the term dy dx in our answer. Keep this in mind. We'll need them when we deal with implicit partial differentiation. Then, as an example, let us look at x squared plus y squared equal to 4. Out of this, we want to find dy dx using implicit differentiation. Before we can start solving the problem, first it is advisable that we take everything to the left and make sure that on the right we have 0. Then we will have x squared plus y squared minus 4, which is equal to 0, like that, as our first step. Then secondly, we are going to differentiate y with respect to x. Then as our first term, x squared, when we differentiate with respect to x, then this is nothing but 2x. Since we differentiate x with respect to x, then we'll just have dx over dx, and dx over dx is a 1. Then plus, we have y squared. We want to differentiate y with respect to x. Then therefore, dy dx of this is 2y. Remembering that we differentiate y, which is a different variable with respect to x, it means we'll always have the term dy dx. Then the derivative of a constant is a 0. Therefore, we equate everything to 0 like this. Then from this, it follows that we want to find dy dx, and then we take everything which does not contain the term dy dx from the left to the right, and make sure that on the left we are left with every term which contain the term dy dx. Then on the left we'll have 2y dy dx, and then we take positive 2x from the left to the right, it becomes negative 2x. We want dy dx, it means now we will have to divide by 2y both sides. Then dy dx must be equal to minus 2x over 2y. So 2x over 2y, 2 will cancel 2, then we will have minus x over y. So this is our answer for this equation. And then let us also try to look at another example. Let me say we are given the following equation: x to the fourth plus 4xy plus y cubed equals to 17. We want to find dy dx. Remember, we said we want to first take everything from the left to the right, and from the right to the left, and make sure that on the right we have a 0. So we have 17. It means now we have to take 17 to the left. So we'll have x to the fourth plus 4xy plus y cubed minus 17. This is equated to 0. Then from now we can differentiate every variable with respect to x. We have x to the fourth. We want to differentiate with respect to x. This is nothing but 4x to the third. dx over dx is a 1, therefore we don't write dx over dx. Then plus 4xy, remember we want to find dy dx, but when we check in this term we have x and y at the same time. So whenever you see a term like this, x and y, of which when you want to find the answer of the requested question, it is given in a form of x and y, it means you have to use product rule to solve such problem. So for now we are going to use product rule in for xy, and then we will first keep for x, then we differentiate y. When we differentiate y, the dy dx of y is a 1. Then remembering that we differentiate y, which is a different variable with respect to x, it means now we must have the term dy dx out of this. Then plus, then we keep the second variable, which is our y. Then we differentiate 4x. The derivative of 4x is a 4. We said we have to keep y, and then we differentiate 4x, and then this will be a 4. Dx over dx is nothing but a 1. Therefore, we'll have plus y cube like that. Then when we differentiate the y cube with respect to x, we'll have 3y squared. We differentiate a different variable with respect to x. We must always have the term dy dx. The derivative of a constant is a 0. Therefore, on the right, we'll have a 0 like this. Then from now, we have to make sure that on the left, we only have the terms which contain dy dx. And then every term which does not contain dy dx, we take it to the right. So we must have 4x dy dx, 4x dy dx plus 3y squared dy dx, and then we take 4y from the left to the right, then we also take 4x cubed from the left to the right. Therefore, it means we'll have minus 4y minus 4x cubed like this on the right. Then on the left, when we check, we have dy dx, which is our common factor. It means we can take it out. Then when we take dy dx as a common factor, inside the bracket we'll have 4x plus 3y squared, which is equal to 4y minus 4x cubed like this. And then now when we check, we want to find the dy dx. It means we have to divide both the left side and the right hand side by this term. So we'll have dy dx equal to minus 4y minus 4x to the third. All this is divided by 4x plus 3y squared. This is our answer for this implicit differentiation. So now let's try to solve the following. So we are given the equation 3x squared z minus x squared y squared plus 2z to the third plus 3yz minus 5. This is 0. Then we want to find dz, dx, and dz, dy out of this equation. So when we want to find dz dx first, remember we said we have to keep everything to the left and make sure that on the right we have a 0. Then our equation is in that form. So after that, it means we'll just go direct into the equation and make sure that we differentiate each and every variable with respect to x. Then we want dz dx. Therefore, as our first term, we have 3x squared z. And we are requested to differentiate z with respect to x. We have zx and we have zx. It means this part can be differentiated using product rule. So let's keep 3x squared, and then we differentiate z with respect to x. Then when differentiate the z with respect to x, we differentiate a different variable with respect to x. Therefore, the derivative of a z is a 1. So it means we must have dz dx always. Then plus, now we keep z, then we differentiate the first term, 3x squared. Therefore, the derivative of 3x squared is 6x. Then we can write it as 6x in front of the z. We differentiate x with respect to x, so dx over dx is nothing but a 1. So minus x squared y squared, we want to differentiate this term with respect to x. Therefore, we just differentiate everything with respect to x, and then we keep y as our constant. It means we must have 2x y squared like that. Then plus 2z to the third. So we differentiate z with respect to x. So this will be 6z squared. Remember, we differentiate a different variable with respect to x. Then we must always have the term dz dx like that. Then plus 3yz. 3yz, want to differentiate it with respect to x. So how can we differentiate this part with respect to x? So when we differentiate this part with respect to x, so it means we are going to have the term since we differentiate with respect to x, then we just differentiate z. It means we'll have 3y like that as our answer. Since we differentiate z with respect to a different variable, then it means we must always have that dz dx. Then the derivative of minus 5 is a 0, then this is equals to 0. Then from now on, we can keep everything that contain dz dx on the left and take whatever that does not contain dz dx into the right. So this part must remain on the left. Then we'll have 3x squared dz dx plus 6z squared dz dx plus 3y dz dx. This term must be taken to the right. So it means now we'll have 2x y squared, because it's negative, become positive. And then this positive will now become negative, minus 6x z. And then on the left we have dz dx, dz dx, dz dx. Then we can take it out as our common factor, dz dx. Then inside the bracket we'll have 3x squared plus 6z squared plus 3y, which is equals to 2x y squared minus 6x z like that. We want dz dx, and then we can divide the left hand side and the right hand side by this expression. Therefore, dz dx is nothing but 2x y squared minus 6x z. All this is divided by this term 3x squared plus 6z squared plus 3y. That's it for the implicit differentiation for this equation dz dx. Then out of this we can also find dz dy. So when we want dz dy, we can write our equation 3x squared z minus x squared y squared plus 2z cube plus 3y z minus 5 equal to 0. So we want to find now dz dy. Then dz dy, when you check on this term, we do not have the variable y, so it means we are just going to differentiate z. Therefore, the derivative of this function with respect to y, we differentiate z, it means we'll have 3x squared. We differentiate z, which is our different variable compared to y. We must have that term dz dy. Then minus x squared y squared. We want to differentiate this part with respect to y, and then we'll keep x squared as our constant, and then we differentiate y squared. So this will be minus 2x squared y, like that. Since we differentiate y with respect to the same variable, therefore we'll have dy over dy, which is 1. Then we don't write dy over dy. Then here we have 6z to the third. We want to differentiate this with respect to y. It means we must have 6z squared. We differentiate a different variable with respect to y. We must always have the term dz dy plus 3yz. Then this time around, when we check here, we differentiate y and z. And the question said, find dz dy. And when we check, these two terms contain y and z at the same time. It means we have to use product rule. So let me first keep 3y, and then I differentiate z with respect to y. Therefore, the derivative of z with respect to y is a 1. Since I differentiate a different variable, it means I must always have the term dz dy with me. Then plus, now I keep z, I differentiate this term with respect to y, 3y. Therefore, the derivative of 3y is nothing but a y. Now I differentiate y with respect to the same term, then I do not have to write dy over dy. Therefore, now minus 5, the derivative of minus 5 is a constant, and it will give us a 0. So we keep everything with the z dy on the left, and then take whatever does not contain the z dy to the right. So now means we'll have 3x dz dy, then plus 6z squared dz dy plus 3y dz dy. This must be equal to, then I take this part to the right, it becomes positive 2x squared y. Then I take this part from the left to the right, then I'll get zy. What happened here? Let me try to check here. I think there's a mistake. I've said that out of this I have to first keep 3y, and then when I keep 3y, I differentiate z, I must get dz dy. Here this is right, plus, then I keep z, then I differentiate 3y, and then this is nothing but a 3. Then we must have a 3 in front of the z. So when we take this from the left to the right, it becomes minus 3z, like this. Then here I will have to take out the common factor. Therefore, dz dy is our common factor. 3x squared plus 6z squared plus 3y will remain inside the brackets. Therefore, on the right we'll have 2x squared y minus 3z. And then lastly, we'll just divide by the expression inside the bracket. And then we'll have dy, dz dy is equated to 2x squared y minus 3z. Then divide this by 3x squared plus 6z squared plus 3y. This is our answer for dz dy. There's another method that we can use to solve these types of problems, which is called the implicit function theorem. Let me try to redo one problem for what we have done using this method and see that it will result us into the same answer. So let me look at this equation. I want to do it using the implicit function theorem. 3x squared z minus x squared y squared plus 2z cubed plus 3yz minus 5 equal to 0. We are going to find dz, dx, and dz, dy. So when you check this equation, this is the function x, y, z. Then this equation can be written in this form: x, y, z, because the function x, y, z. And then this is nothing but 3x squared z minus x cubed, x squared, y squared plus 2z to the third plus 3yz minus 5. So now when we check, we have the function x, y, z. We want to find dz, dy. Differentiate this equation with respect to each variable of f. So first let's find f sub x. F sub x will give us, we differentiate this equation with respect to x, then when we differentiate this part with respect to x, we'll have 6x z minus, we differentiate this part with respect to x, 2x y squared, then we differentiate with respect to x. Therefore, since we do not have the variable x, and here, it means we treat them as constant, and the derivative of constant is a 0. So this is what we have for f sub x. We also have to find f sub y. So let me find f sub y. We differentiate the same equation now with respect to y. The first term does not contain the variable y, therefore it's a 0. Second term, there is variable y, we differentiate it. So this is minus 2x squared y. Then plus, now we have to add the derivative of this part with respect to y. There's no variable y, and then this is 0. And then this one with respect to y will give us 3z, like this. So let us now find f sub z, and then we differentiate this part with respect to z. Differentiate this, we'll have 3x squared minus, there is no variable z, then this is a 0, then plus 6z squared, and plus, we differentiate this with respect to z, is nothing but 3y, then minus 5, so it's a constant, will give us a 0. So let's first find dz dx. So according to the implicit function theorem, it says that we must have the negative of f sub x over f sub z, which implies that dz dx is nothing but minus f of x. We have said that f of x is this part, and then we write 6xz minus 2xy squared. This is divided by f of z. Then this is our f of z, which is 3x squared plus 6z squared plus 3y. And then multiply the negative inside. This is nothing but 2x y squared minus 6xz divided by 3x squared plus 6z squared plus 3y. So this is what we get for dz dx. We can compare this answer as the answer which we have got using the first method. when we check in the first method, we had 2xy squared, 2xy squared minus 6 squared. Yeah, everything is just the same. So let us also try to find dz dy. dz dy. dz dy will be given by the negative of f sub y over f sub z. So we have said that f sub y, we found this expression, so we'll have minus 2x squared y plus 3z. This is divided by f sub z. So f sub z is this expression here. Then this is 3x squared plus 6z squared plus 3 plus 3y like that. And then we multiply the negative inside. So this is more like we have 2x squared y minus 3z divided by 3x squared plus 6z squared plus 3y. Let us now relate this answer from the previous answer which we have got. And then in the previous answer we had 2x squared y minus 3z over everything. So when you check, these answers are the same.